In this lesson, we're going to be looking at analyzing patterns and looking at relationships between two patterns. So first of all, here I have a simple pattern. The first thing we're always going to do is look for the rule to the pattern. But before we get there, we need some vocabulary. So a pattern is a pattern is a series of numbers or figures that follow a rule. So then a rule tells how the numbers in a pattern are related. This might be a new word. The term is a specific number or figure in a pattern. You're going to need to know the difference between pattern, rule, and term. So if we go back to this, our pattern is just these numbers in order, a series of numbers. This would be the first term, the 0 would be the second term, the 6 would be the second term, the 12 would be the third term, and 18 would be the fourth term, and so on. So the rule, you could see, is adding 6, but we always write our rules with a variable, a letter, and then the operation. So the rule for this pattern is n plus 6. Alright, take a look at this pattern and see if you can figure out what the rule is first. I notice that I'm decreasing by 50 every time, so the rule is n minus 50. And what would the next term be if we are decreasing by 50? Well, 350 minus 50 is 300, and we could keep going for many, many terms. Alright, I want you to pause the video and see if you can come up with the rule and the next term in this pattern. The rule for this pattern is n times 2, or more commonly wrote as just 2n, because remember that means multiplication. And then the next term would be 96. Sometimes we have patterns that are a bit more difficult. When I look at this pattern, I notice that my numbers are increasing in value, which tells me we're probably adding or multiplying. So if I try add, it's add 1, then add 2, then add 4, then add 8. So that is not a pattern. That's not a rule. If I try multiplying, there's no whole number I can take times 2 to get 3. So this must be a combination of two operations. These get a little bit trickier. It kind of takes some guessing and checking until you can figure out the rule. So if I take 2 times 2, that gets me to 4, but then I need to subtract 1 to get to 3. If I take 3 times 2, I would get 6, and then subtract 1, I get 5. So I just found that the pattern is taking the term times 2 and then subtracting 1, because 5 times 2 would be 10, subtract 1, 9. 9 times 2 would be 18, subtract 1, 17. So what would the next term in the pattern be? Well, 33 times 2 is 66. Subtract 1 would be 65. All right, the next thing we're going to do is relate two patterns. So as you can see, I have two patterns here. I want you to pause the video and find the rule to each of these patterns. Alright, so the rule to the first pattern is n plus 3, and the rule to the second pattern is n plus 6. Now, the trickier part. The terms in the second pattern are blank the terms in the first pattern. They are wanting us to compare corresponding terms. This is what it means. First term to first term, second term to second term, third term to third term, and so on. What is the relationship between all of these numbers? So you need to ask yourself, what can I do to 3 to make it a 6? What can I do to a 6 to make it a 12? And so on. And I notice that all of these multiplied by 2 become the second pattern. So we would say the terms in the second pattern are 2 times the terms in the first pattern, because all of the numbers on the bottom are 2 times bigger than their corresponding term in the first pattern. Okay, I want you to pause the video, find the rule for both patterns, and then see if you can find the relationship between the two patterns. The rule for the first pattern is n plus 2. The rule for the second pattern is n plus 8. So now, what are the relationships between the corresponding terms? And I'm noticing that the first rule times 4 gives me the corresponding terms. So the terms in the second pattern are 4 times the terms of the first pattern. You will often see two patterns that have a relationship in a table like this one, sometimes called an XY chart, and we always start with the top and think about what's happening to these numbers to become these numbers. So here I'm recognizing that every number is being multiplied by 20. So now we want to use variables that make sense. So balloons and cost is the main relationship. So we could say that balloons times 20 equals the cost. But you would probably most often see this as cost is 20 times balloons. All right, at this point you need to find some grid paper, or in the back of your coach book there's a little bit of grid paper. So go ahead and grab that. What we're going to do next with these patterns and relationships between patterns is change them into ordered pairs, which you have worked with before. So a little review, ordered pair is two numbers that give a location on a coordinate plane, and they are always written in parentheses. So for example, 5, 3 is an ordered pair, or 1, 2 is an ordered pair. These are going to be put on a coordinate plane. Coordinate plane is a grid, which is why you grabbed grid paper, formed by a horizontal line across called the x-axis and the vertical line up and down called the y-axis. Coordinate plane looks like this, x, y, and every point on here is an ordered pair. So for example, this point right here would be 2, 3. We always say our x coordinate first and then our y coordinate. I want you to take a couple minutes, pause this video, and write the ordered pairs for all 4 of these red points. Okay, check your ordered pairs. Do they match what you see? Sometimes points on the x-axis or on the y-axis can be confusing because they have a 0 in them. Remember, we always go right, or we always get on the elevator before we go up or down. So this would be 4, 0, and this would be 0 because we don't go to the right, we only go up 7. So 0, 7. One more key word you need to know is origin. The origin is the point where the axes meet on the coordinate plane, otherwise known as 0, 0. So where we always start at point 0, 0 is called the origin. So what we're going to do is use this chart, not always x and y, it can be any letters or any information. We're going to find the rule or the relationship between j and k. Then we're going to make ordered pairs out of that information, and then we're going to put it on the grid. So first thing, the rule. If you look from J to K, what is happening to J's to become k's. And I'm noticing that all of my j's divided by 2 equal my k's. So the rule would probably be written as k equals j divided by 2. Now, for ordered pairs, you're just taking your corresponding terms and writing them as ordered pairs. So our first ordered pair is 2, 1. Our second ordered pair is 4, 2, and so on. 6, 3, and 8, 4. The next thing we need to do is label our x and y axis, or here are j and k's. My j's are counting by 2's, so on my x-axis, I'm going to count by 2's. And my k's, or my y's, are counting by 1's, so I'm going to label these counting by 1's. And then we just need to put our ordered pair on the grid. So 2, 1, 4, 2, 6, 3, and 8, 4. Now we could continue both patterns, and it will continue our straight line. If you found the rule and ordered pairs correctly, it should form a straight line. All right, I want you to use the information you see on your screen and a grid, complete the table, find the rule, write the ordered pairs, and then label your x and y axis and put the ordered pairs on your grid. Go ahead and pause the video and complete all of that. This is hopefully what your information looks like. The rule can be written in a few ways. Just make sure you're multiplying m and 4. The p is the part that's by itself. The last part of box 3A is an Edmodo online assessment. So go ahead and find that. Click on the link and take the 10-point quiz.